Welcome to BTEC Revision. Today we're going to be looking at how to simplify and calculate solutions using the laws of logarithms. Last lesson, we looked at how to write logarithms. If we have a base b to the power of p, that's equal to a number n. For example, if we take 10 to be the base to the power of 2, that's going to be equal to the number 100. In logarithm notation, we can write this as log b, which is 10, to the number 100 is equal to the power 2. There's a set of log rules that we can use to help us to manipulate logs. First log rule is log a times b is equal to log a plus log b. For example, if we take log 2 times 3, that's equal to log 2 plus log 3. Log 2 times 3 is also equal to 6, so we can write that as log 6. We can also write this equation in reverse. For example, if we take log 10 plus log 5, that's equal to log 10 times 5, which is equal to 50. The second log rule is log a divided by b is equal to log a take away log b. Let's take, for example, log 10 divided by 5. That's equal to log 10 take away log 5. Log 10 over 5 is also equal to log 2. So we can say that log 2 is equal to log 10 take away log 5. We can also write this equation in reverse. We'll take log 20 take away log 10. That's equal to log 20 divided by 10, which is equal to log 2. Third log rule is log a to the power of p is equal to p multiplied with log a. Let's take, for example, log 10 to the power of 2. We can write that as 2 log 10. We know that 10 squared is 100, so we can write log 10 squared to be equal to log 100. Therefore, log 100 is equal to 2 log 10. Writing the equation in reverse, we can say 10 log 2 is equal to log 2 to the power of 10. For the fourth rule, we can say that log to any base of the number 1 is always equal to 0. To understand this rule better, we can write this in exponential notation. So we can write this as base to the power of 0 is equal to 1. And any number to the power of 0 is always going to be equal to 1. For the fifth rule, log to the base b of the number b is always equal to 1. Putting this in exponential notation, b to the power of 1 is equal to b. So we can see the reason why. Log rule number 6 is telling us that log to the base b of the number b to the power of p is equal to p. Let's write this in exponential notation to see why. So here we have the base b, and we have the power of p, and that's equal to the number b to the power of p, which is over here. Finally, log rule number 7, we can say that b to the power of log base b a is equal to a. For example, let's take 2 to the power of log base 2 of the number 10. That's going to be equal to 10. This is the summary of the laws of logs. One important point to note is that log 0 is not defined. Let's put this in exponential notation. We have the base 10 to some number x. Can you think of a number that would give 0? It's impossible. So there is no value of x that we can have here for 10 to the power of x to be equal to 0. All these rules apply for natural logs as well, because natural logs are logs to the base e. And these rules apply for any log to any base. So naturally, they would apply for natural logs. Now pause the video here and attempt these questions. Starting with question 1, we can see that the bases are the same, so we can use one of the log rules, which is the first one. So that's log 2 to the number 2 times 4, so that's 8. We can simplify this further. When putting this in exponential notation, we can see that 2 to the power of some number is equal to 8. And we know that 8 is equal to 2 to the power of 3. So we can say that x must be equal to 3. Question 2, we can see that the log bases are not the same. So we can't use one of the log rules, so we have to find a different way. We can simplify. If we put these in exponential notation, we can say that log 2 to the number 16, we can write that as 2 power of x is equal to 16. And this must be equal to 2 to the power of 4, because 2 times 2 is 4, times 2 is 8, and times 2 again is 16. So that's going to be 4. Looking at the second value here, we have log to the base 4 of 4, and that's going to be equal to 1. So therefore we can simplify. First number was 4, second is 1, so 4 take away 1 is equal to 3. For question number 3, we can divide first, and we will get log base 4. So 80 divided by 5 is equal to 16. Now we can put this in exponential notation, which gives us 4 power of some number x is equal to 16. And 16 is equal to 4 squared. Therefore, x is 2. Question number 4. There's two ways we can do this. We can firstly write log to the base 2 of the number 2 cubed. 2 cubed is equal to 8. So we can write this as 2 to the power of x is equal to 8. So therefore, x must be 3. And the second way we can write this is if we bring the power down using the power rule. So that would be 3 log to the base 2 of the number 2. And we know log base 2 to the number 2 is equal to 1. So therefore, that's 3 times 1, which is equal to 3. For question number 5, we can see that we have log and there's no base. So when there's no base written, we can assume that to be 10. So therefore, we can write this as 10 to the power of log base 10 of the number x. And using log rule number 7, we know that this is equal to x. For the final part of the lesson, why don't you solve this exam question? So to solve this equation, you would need to firstly bring the powers down. So that would give us x plus 1 multiplied by log the base 10 to the number 10, which is equal to 2x plus 1 times 2, put that at the front, multiplied by log base 2 of the number 8. Now we can simplify this equation. We can have x plus 1 multiplied by log base 10 the number 10, which is just 1. It's going to be equal to 2 times 2x is 4x plus 2 multiplied by log base 2 of 8. So we should know that is equal to 3. So times 3. This is simplified to 4 times 3 gives us 12x here, plus 2 times 3 is 6, and x plus 1 is equal to that. Finally, we can collect like terms, so that gives us 1 take away 6 is equal to 12x take away x. So therefore, negative 5 is equal to 11x. Finally, 11x is equal to negative 5, so x is equal to negative 5 over 11. And that's the end of the lesson. Thank you for watching. And if you would like to boost your grades, why don't you try some quiz questions, and there's lots more resources available at btecrevision.com.